Leetcode problem 3115, maximum prime distance, maximum prime difference. Yeah. So for this problem, we are giving an array nums, and inside definitely there is at least one prime number, and we're gonna check the maximum distance. Yeah, because here we need to check the constraints. It is said there's gonna be at least one number, which is gonna be a prime number inside of the nums array, and as we can see for the first example, this 2 is a prime number and this 3 is a prime number, and the distance is going to be 3, and that's going to be the maximum distance. Of course 2 and 5 are okay, but the distance is 2, it's not the maximum, so we're going to return 3. So how can we solve it easily? Let me just maybe just copy some method, because definitely we're going to use. Yeah. So if we are using the Euler algorithm to check the prime number, it's going to be this one, is prime. If we are going to use the arithmetic algorithm, it's going to be this one. Yeah, so let's just copy those two. Maybe we want to use the Euler first. Let's just use it. Yeah, I mean, if we copy some code, definitely we know how to write it, but here just for saving some time. So this is just the Euler's algorithm to check if a number is a prime number. Yeah. Now we're going to prepare a minimum index and maximum index, so definitely we can find that. So we can set it from 0, 0, because definitely we're going to update that, because this 0 and 0 doesn't matter, we're going to update it. So for I enumerate the nums, we're going to use this h prime with the number to check. If this h prime, we're going to check the minimum index, which is going to be the it's going to be the minimum index with this index I. And at the same time, we can update the maximum index. It's going to be the maximum of the maximum index with this I. And finally, we just need to return the max index minus the minimum index. Now let me run it to check if it works. It didn't, and let's just check what happens. It is 4. Oh, this is a little bit strange for me. Why it is 4? It should be 3. Let me just check. This is a little bit strange for me. You know, I just use copy and paste to check its prime, but it didn't work. Let me just run it. Yeah, the maximum index is 4, it is okay for this 3, but the minimum index, definitely it is not 0, it should be 1, because 4 is not a prime number. So it seems I copied something wrong. Let me check. Oh, this is why I did it wrong, because I set the minimum index to be 0. 0 compared with other indexes should always be always be 0. That is why it is wrong. So from here, maybe I want to set infinity, because I want to check the minimum, and here I'm gonna check a negative infinity, because I'm gonna check the maximum. So in this way, definitely I'm gonna set the right minimum and maximum index. So this is also important for us. So let me just run it. Now as you can see, it works. Now let me just submit it. I think it's going to be a little bit slow, but at the same time, let's just analyze the time complexity. So for the time complexity, it depended on the length of the nums. From here, it is 10 to the power 5, and from here, this is another way. Maybe it didn't work. Yeah, because for this one, it is the square root of n. The square root of n, this number is going to be really big. It's going to be 10 to the power of 2. This means it didn't work. If it didn't work, we're going to use another algorithm. We're going to use the arithmetic algorithm to solve it. Yeah, maybe it didn't work. Let's just check. And because 10 to the power 5 times square root of the number, it works, but it's really slow. Let's just check the number. As you can see, it works, but the number is just 100. So the square root of 100 is going to be a really small number. So it's going to be 10. 10 times 10 to the power of 5 times 3. So this is going to be the time complexity. It's going to be 3 times 10 to the power of 6. So this is going to be the time complexity for this one. So maybe we don't like to use the Euler's algorithm. What about we want to use Aristotle's algorithm? So Aristotle's algorithm is from here. Let me just copy it. So I don't want to write it. So maybe for you, while you are writing the code, maybe you're going to prepare a lot of libraries for you to use. So definitely you know how to write it before you copy it, I mean. So let me copy it from here. So this time we're going to use the Aristotle's algorithm. And the maximum number, let's check here. It's going to be 100. So inside, we're going to use 100 as our maximum number. So from here, we're going to use the primes directly to check if it works. Let me just delete it here. So we're going to change it to h prime with this number. Yeah. So if it works, we're going to check the maximum and minimum. Let me just run it. As you can see, it works. Let me just submit it to check. As you can see, it works, and it is much faster than the previous one. Why? Let's just analyze the time complexity. So for the time complexity, for here, this is just 100. Yeah, basically we can ignore it. Yeah, so it's going to be the maximum of 100. It's going to be the maximum of 100, this one, because this just runs one time. And of this one, this is n. n is 10 to the power 5. Yeah, so in this way, we reduce the time complexity from 10 to the power 6 to 10 to the power 5. So this is why it is better. Yeah, I think this is why we need to learn both of the algorithm, the Euler's algorithm and Aristotle's algorithm to solve the h prime problems. Yeah, I think that's all about it. Thanks for watching. See you next time.